Lesson 2.3, Video 1. Using elimination to solve a system of equations. In this case, we're going to look at a very specific form of elimination, and that's just addition. Elimination, unlike substitution, is very interesting because you are going to solve a system of equation by adding two equations. And in the process of adding two equations, you will eliminate one variable. But you have to have it set up properly to do so. So just like substitution, where you have to get one equation solved for a variable, this one takes some steps to prepare also. So we are going to write the systems of equations so like terms are aligned. And what that means is you'd have something like this. 2x plus 3y equals 1 over x minus 2y equals 8. And by alignment, we mean that the x's are right above each other and the y's are right above each other. And they are on the same side of the equation. Another piece is to determine whether the equations need to be multiplied by a constant so that the two equations contain opposite terms. Now in this case, in the example I gave you, you have a 2x and an x. They are not opposite terms. And then your y's are a 3y and a negative 2y. They are not opposite terms. You'd want something like this. You'd have a 2x plus 3y, and then you'd have a negative 2x minus 2y equals 8. Here's a situation where you have opposite terms, and that's what you're looking for. Once you have that, you're going to add, and we do not subtract, so we can ignore that part. But we will add the two equations together, and in doing so, in this particular case, they would cancel out, and you're left with one variable. In this case, it would be y equals 9. So I would add my y values, I would add my constants on the right, I would add my y values, and I would get something solved for a variable. Now this one was y equals 9, but if that's not the case, then you do have to solve the equation that results for a variable. Like I said, this one happened to be already solved for a variable. And then, like always, you need two values, an x and a y value. So you would plug in the value you get, but now you can plug it into either equation, and then you would find your other variable. So again, we're looking for a coordinate where the two lines, if graphed, would intersect. Alright, so let's take a look. Solve the system by elimination. Now, as we mentioned, they are aligned. X's are above each other, Y's are above each other, and they're all on the left side of the equation, and your constants are on the right side of the equation. Notice that my y's have opposite values, which is good. So now we can solve this by addition. So if I add them together, we get 9x's, negative 7y plus 7y cancel. Negative 11 plus 20 is 9. And here we have an equation that needs to be solved. And we get x equals 1. Again, we're looking for a coordinate, so my x value is 1. I'm going to take that value and decide which equation I should plug it into. And either one would work. So I'm just going to take the top one arbitrarily. I'm going to plug a 1 in for x because that's what our x value is, and solve that equation for y. So we get 3 minus 7y equals a negative 11. I'm going to subtract 3 from both sides in the process of solving, and we get negative 14. I divide by negative 7 to undo the multiplication, and we get y equals 2. So our coordinate of intersection is 1, 2. Our solution is 1, 2. And if we plugged 1 and 2 into both equations for x and y respectively, it would be a true statement. This ends 2.3 video 1.